Hello everyone. Today in this video I explain you about the Lorentz Force Law. First we see about what is Lorentz force. Lorentz force or electromagnetic force is defined as the combination of the magnetic and electric force on a point charge due to electromagnetic fields. It is used in electromagnetism and is also known as the electromagnetic force. In the year 1895, Hendrik Lorentz derived the modern formula of Lorentz force. The force experienced on a charged particle due to electric and magnetic fields is known as Lorentz force. We know that the electrostatic fields exist due to charges at rest. The magnetic field exists due to permanent magnet, motion of charges, or current elements. When the charges are in motion, they are surrounded by a magnetic field. The flow of charges constitutes an electric current. So, a current carrying conductor is always surrounded by a magnetic field. If a current flow is steady, then the magnetic field produced is also a steady magnetic field. The direct current is a steady flow of current. Hence, the magnetic field produced by a conductor carrying DC current is a steady magnetic field. The study of steady magnetic field produced due to the flow of direct current through a conductor is called magnetostatics. Consider some point charges Q1, Q2, Q3, etc. at distances R1, R2, R3, etc. from the test charge Q. According to the principle of superposition, the total force acting on a test charge due to all other charges is F is equal to Q into E. In the first figures, two wires hang from the ceiling a few inches apart. When the current passes up one wire and back down the other, the wires jump apart. They repel one another. The current flow of both wires, they attract one another. So we know that currents in opposite direction, it repels. Currents in same direction, it attracts. So a stationary charge produces only an electric field E in the space around it. A moving charge generates a magnetic field B. The third figure, the right hand rule is useful to find the magnetic force. If you grab the wire with your right hand, the thumb in the direction of the current, your curled fingers around in the direction of the magnetic field. So it is understood that the magnetic force is perpendicular to both the magnetic field and charge velocity. So the last figure shows the two current carrying wires can attract or repel each other since each experiences a Lorentz force from the other's magnetic field. The velocity of the charge is upward and the velocity of the resulting force is to the left. So, to find out the Lorentz force. So, in a given magnetic field, the magnitude of the force on a charge is proportional to the magnitude of the charge Q and to the speed V of the charge. Consider a uniform magnetic field of induction B acting along the z-axis. A particle of charge Q moves with a velocity V in the YZ plane, making an angle theta with the direction of the field. Under the influence of the field, the particle experiences a force F. So the magnetic force is equal to Q into V cross B. The force experienced by a charge Q in an electric field E is equal to Q into E. So the total force is equal to magnetic force plus electric force. So that is equal to Q into V cross B plus Q into E. So in the presence of an electric field E and magnetic field B, the total force on a moving charged particle is Q into E plus V cross B. So this is Lorentz Force Law. So the term QE is called the electric force, while the term Q into V cross B is called the magnetic force. So here asking the question, why the magnetic forces do no work? So the magnetic force, suppose if Q moves an amount dl is equal to V into dt, the work done is equal to Q into V cross B dot B into dt. So we know that V cross B is always perpendicular to V. So V cross B dot B is equal to 0. So the force always acts perpendicular to the direction of motion of the charge. The force does not do any work. Next, applications of Lorentz force. Cyclotrons and other particle accelerators use Lorentz force. A bubble chamber uses Lorentz force to produce the graph for getting the trajectories of charged particles. Cathode ray tube televisions use the concept of Lorentz force to deviate the electrons in a straight line so land on specific spots on the screen. Thank you.